Hi everyone, my name is Parag Pal and welcome back in my new video. In this video, I'm gonna solve the numerical based upon the bolt connection, okay? And we are gonna design the joint, right? And also we are gonna provide a suitable pitch for this bolt, right? So this is my lecture number 4, and I hope that you will watch this video till the end so you can understand in very proper way, right? So now let's get started. So first of all, let's understand what are the details available in the numerical. So there is a two flats, okay? What does it means? These are the two flats, okay? Two plates you can consider. This is first plate, this is another plate. Fe 410 grade of steel. So we have a grade of steel of this plate which is Fe 410. It means it is a value of Fu. Understand? Now each plate is having dimension of 210 mm by 8 mm. It means this is a distance, okay, 210 mm, and the thickness is 8 mm, right? Are to be joined using 20 mm diameter of bolt. It means what? That we are gonna design a bolt over here, okay, this bolt, okay, and it will join these two plates, right? Now we need to calculate how many number of bolts we required and what would be the distances. It means edge distance and the pitch distance. After this, after identification of all these things, to form a lap joint, okay, they mentioned they want to make a lap joint. The joint is supposed to transfer the factored load of 250 kilonewton. So we do have a load in place also, correct? Now we need to design the joint and determine the suitable pitch for the bolt. So that is the concern. Now whenever they ask us to do the joint, it means VDPB and VDSB is the two value that we need to calculate, and whichever is the smaller, that will be the design, that will be taken for a consideration of the design of bolt of the joint, right? And also we need to calculate the pitch distance over there, correct? Now you can see guys, here I have already calculated the VDSB and the VDPB. I can just show you, okay? So you can understand at the start of the numerical itself, okay? You can see that the design no need revision because VDPB is 78 and VDSB is 45, right? So these are the two values that we need to calculate. Now remember one thing, if you see there is a lots of things I have written here, no worries at all, because the formula already given in IS code 800 2007, which is the limit state of method IS code for Indian standards, correct? And all these formulas are mentioned over there, correct? Now this is one of the very important numerical for all of you. Now, so first of all, whatever we have to do, let's understand the calculation of the shear strength of the bolt. So shear strength of the bolt, it means first we calculate VDSB. So to calculate the VDSB, formula is VNSB upon gamma MB, and this is a partial safety factor, okay? Partial safety factor. So VNSB is having a very concise formula which is FUB upon under root 3 N into ANB, NS into ASB divided by 1.25, which is the value of the gamma MB. So now put all the values, because we have FUB as a 400, NS equals to 1, ASB, ANB we have 245, but we are putting NS value equals to 0 over here. Why? Because there is a no shear plane without thread is expected to intercept in this type of the failure. So in this type of failure, we are not expecting any shear plane. So that's the reason we are keeping the value of NS equals to 0, right? So this whole function will get 0, okay? Now if you put this value, you got the value of VDSB, okay, as a 45,264. It means 45.26 kilonewton. Now let's calculate the number of bolt required. Now you can see the diagram over here. So this distance, okay, this distance define the pitch distance, okay, and this distance define the edge distance, right? So all these things what I have written here, these are very important for all of you, because without this you can't solve the steel structures numerical. So now let's calculate the number of bolt required. How many number of bolt you required with respect to this design value? So we do already have a factored load. We need to divide that with the VDSB. So factored load is 250, which is already given in the numerical here, 250 kilonewton, and VDSB is 45.26. So value become 5.52. So guys, we can't put the value of bolt as a 5.52. We need to make it figure out the next figure, which is 6 number of bolt. So you can see this is a plane. In this plane, we are assigning these two line, right? So 3 bolt on this side, 3 bolt on this side. So this is a way that we are going to do this design of the bolts, right? Now don't look at the figure right now, because that we need to calculate. This figure we need to calculate, this figure we need to calculate. I just skipped here because I just want to show you how it will be look like. Okay, now you can see that strength of the joint per pitch length on the basis of the shear of the bolt that you need to calculate. Okay, so strength of the joint, you need to calculate the strength of the joint per pitch length. So it will be calculated as a TDN, and TDN means you need to multiply this value of the VDSB, okay, multiply by 2. So you get the value of 90.52. This is a very simple calculation. Once you calculate the shear strength of the joint per pitch, you need to use that one to equate, to identify the pitch length. So we are using this value, this formula, to calculate the pitch value. So the formula is TDN equals to 0.9 FU upon gamma M1 into AN. But now let's understand what is the AN. AN is nothing but pitch minus diameter of bolt, okay, into thickness. So just put this value of AN over here. So your formula become TDN equals to 0.9 FU upon gamma M1 P minus DH into T. Now put all the values. So we have TDN value over here, which is 90.52. This is in kilonewton. We convert into Newton. So it is 10 to the power 3 equals to 0.9 as it is. FU is 410. Gamma M1 is 1.25. Pitch we need to calculate minus 22 into 8 is the thickness which is given at the top. This is the thickness, right? Now you can see, guys, once you solve this in your calculator, you can see the value of pitch equals to 60.33. Now you need to check this value with respect to this formula, which is pitch equals to 2.5 into diameter. So 2.5 into diameter is 20 of the bolt, so it is 50 mm. So whichever is a higher, take that one. So I am taking 60.33, but still I cannot assign the value of 60.33 as a pitch. So I am going to add up the next similar value of the 65 mm as a pitch. Right? Now let's identify the edge distance. So edge distance calculation is very simple. Whatever that edge total length is 210 mm, correct? So 210 minus 2 into pitch distance divided by 2. So you will get the edge distance, which is E. Now we have the pitch distance and edge distance over here. So we mention edge distance and pitch distance here. Understand? Now, after calculation of this, guys, we need to also calculate the VDPB. To calculate the VDPB, the formula is VDPB equals to VNPB upon gamma MB. VNPB formula is 2.5 into KB into D into TP into FU divided by gamma MB. This formula is given in IS code 800/2007. Now, to calculate the KB, this process you need to follow, right? So this formula also given in the IS code 800/2007. So E upon 3 into DO that you need to first solve. So which is H is a 40, 3 into diameter along with the hole is 22, so it is 0.6. So it is already we have calculated at the top. Everything with us now. Okay, this is 22, right? Now then pitch upon 3 into DO minus 0.25, so it becomes 65 is a pitch distance, 3 into DO is a 22 minus 0.25, you get 0.73. Now next one is FUB upon FU, which becomes 0.97, and the 1 is a unit always. Now whichever is the smallest, 0.6 0.73, 0.97 and 1. So smallest is 0.6. It means KB value is 0.6, right? Now let's proceed for the upload all the data in this VDPB value formula. So 2.5 into 0.6 into 20 is a D, TP is a thickness 8 and FU is a 410, which is the grade of the steel which is given over here, 410, right? Now divided by 1.25, which is a partial safety factor, and value becomes 78.72. So guys, understand that this value is higher than the 45.26. It means our design, whatever we did design at the top, see, this design we did with respect to, this is a design, okay, this design with respect to the edge distance, pitch distance and the VDSB is with respect to the VDSB, we calculate the number of bolt, edge distance and the pitch distance. But what happened is VDPB is higher. It means we no need to design with respect to VDPB. We need to select the smallest value. If this VDPB is smaller than VDSB, then we do have revised our design. Okay, and we need to recalculate the number of bolt, and the edge and pitch distance with respect to that one. So in this scenario, our VDSB is smallest than VDPB. It means our design, whatever we have done at the top, is safe and required no revision, right? So I hope you find this video helpful. This numerical is very important for all of you. Okay, moving forward, I'm expecting your appreciation, your subscriptions for my YouTube channel. Just subscribe. This is a free channel for all civil engineers and project managers. I hope you like this video. Have a nice day. Bye bye.